Hello, welcome back. We're going to talk about some very interesting topic right now called as special permissions. You have already understanding of these basic permissions here: read, write, and execute. So I'm assuming that we know how to set up these permissions using the chmod command. That kind of understanding we already have. Chmod for user, give execute on a file called as a.txt, or similarly you can give a group at a group level, maybe a write permission, something like that. If you want to take it out, you can remove it at a group level or at the other level, and then minus is to remove, and maybe read, write, and execute, all of them can be removed. So likewise, we know how to use the chmod command at the user level, at the group level, at the other level. We can give the permission using the plus sign, and we can take away the permission using the minus sign. So this basic knowledge we already have. Now we are going to jump into the next topic, which is the special permissions, and then after that we will jump into another topic related to permission, which is called as ACL. So right now my focus is only this thing, which are the special permissions. There are three types of special permissions: the sticky bit, then the SGID, and the SUID. So we'll go to each of them with a specific reason there, with a specific purpose. They have been defined or designed for a specific purpose. Sticky bit, this is set for directories, and I will show you now a very important directory to which this sticky bit is always set. You see here temp directory. All of us, we know that we can write files to the temp directory. Any person, any user, it doesn't need to be root, can write or create files and directories in the temp directory. And why can you do that? See the ownership of the file. The owner of the file is sorry, not the file, the owner of the directory is root. The group of the directory is also root. Now if you see, the owner can do read, write, and execute. Anybody from that group root can also do read, write, and execute. And then as you see the permissions for the others, you will see read, write, and T. T is that sticky bit. Now what is the reason for putting the sticky bit over here? By putting the sticky bit over there, even if you are not root, even if you are not a member of a group called as root, you can still go inside that and create the file because of that read, write. And then on top of that, when you create a directory, so let us say mkdir, I create a directory called as pqr. As you can see, I'm able to create my own directory called as pqr. I am the owner. My group is my primary group, which also happens to be Shaker, and I have created this directory. But can anybody else delete that directory? Can anybody else make changes to that directory? And the answer is no. And why? And the reason is because of this T. If this T was not there, then anybody could have come inside and deleted my files or directory. So because of this T, the sticky bit, I am able to create the files and they are getting protected. So because of the T, the delete protection is given to my files, to the owner of the files. So other people cannot just go. Otherwise, if this T was not there, because of the write permission, anybody could delete the file in that temp directory. So that is what the sticky bit is. So if you don't want other people to delete the files in a specific directory, but you want them to create the files, then make sure that you set this sticky bit. And how do you set this thing? Let us say now I create another directory. In fact, I have created a pqr directory, right? tmp pqr. You see, no, not. I don't want to go inside that. So pqr, I want to put a sticky bit to that. So chmod, it's o plus t p pqr, and now you can see the sticky bit has been set here. So delete permission is there. Obviously with the sticky bit you must give the write permission, o plus w, otherwise it wouldn't make any sense to give the sticky bit. So now what has happened, if you see, I have given the write permission to my pqr directory. That means anybody can come and create files in that directory, and on top of that I have protected all the files that have been created so that only owner can delete that file by applying the sticky bit. So delete protection is provided by the sticky bit. So that is what our discussion for sticky bit is. Now the next discussion is the SGID bit. This is also for the directories. Now let me create another directory called as mkdir/temp/xyz. Now if you see the permissions of these directories, it is a standard permission. Anybody in the shaker can do read, write, execute. Anybody from the group shaker can do read, write and execute, and others can only read and execute. This is the permission for directory XYZ. Now I'm gonna set a group as SGID bit. So this is how you set that, X, Y and Z. So for the group you are setting a S bit, and now see how the permissions look like. You will see here an S. Now what is the advantage of having an S there? The advantage of having an S is for collaboration, which means you have created this directory XYZ and you have given people permission to write in that directory. So let me now make it also others plus write on that XYZ. Others plus write will show you that everybody can write to that. But one important thing is that SUID bit is set, and because of this, any file that gets created inside this directory XYZ will have a group membership of shaker. Let me repeat. Any file that gets created inside the XYZ directory will have a group membership of shaker, which means the group membership of the parent directory. So let me now log in as let me log in as somebody else, cat etc, or let me exit first. Okay, it is taking some time to log out. I'm having some security setup, so it is doing all this stuff, and then I'm gonna log in as somebody else, etc password. I have a user called as I2 here, so I'm gonna do login as I2. Now I2 is logged in. I2 is gonna go to the temp directory, and if I2 creates any file, first thing, let us see what are the groups of I2. I2 is a member of a GID, also I2. So if I2 creates any file, p.txt, see what are the default permissions of p.txt. The owner is I2 and the group is also I2. That is how this is the primary group of I2. So this is a standard thing. But now if I2 goes inside the XYZ directory, and for the XYZ directory we have the SGID bit set, and now see touch q.txt, and now see what happens here. I2 is the owner, but the group is not I2 like this. The group is shaker, and that has happened because of the SGID bit that we have set. So now let me repeat, SGID bit is usually set for the directories, and any file created in that directory will have the group ownership of the directory itself. That is what the SGID is. Okay, that is how you set the SGID, and this is done usually for the collaboration. That means we are a member of some team, and then the team's name is Java developers, and all the files that should get created in that specific directory should have a group ownership of Java developers. So this is how it can be implemented by setting up the SGID bit. And then the SUID bit, this is set usually for the files. Okay, now the next topic, SUID. Okay, Now this is how the SUID is set for a file, and this is usually set for the executable files. So this is my txt file, so it wouldn't make any sense to set up, but just for our demonstration I'm going to show it. U plus S, G plus S is SGID, and U plus S is set UID, SUID, and the file name is q.txt. So now see the permissions here. There is a S bit that has been set here, and because of this S bit, okay, the file has to be first executable. Now this is not, as I said, a good example. This file must be an executable file. So what happens when you execute, when any person executes this file, then for the duration of that execution, that may be 1 millisecond or 2 milliseconds, the person who is executing, the user who is executing the file, will act as if he is the owner of that file. And the best example that I can give you is in the bin directory. There is a file called as passwd. I'm logged in as Shaker, so let me log out and go back as root. I'm logged in as I2. So I'm going to show you a special file for which this SUID is set. Bin -l passwd. What is that? No access. Do you see P or which? Oh, it is not in passwd. It is in sorry, it is not in bin. It is in user bin. USR ls-l passwd. So this is the file we use, or this is the command we type to change the password. Any user can type this command and he can change the password. Now where are the passwords kept? They are kept in a file called as etc shadow. Now if you take a look at the permissions of the etc shadow, you will see the etc shadow, nobody has any permissions to do anything there. But then if nobody has permission to do anything in this file, how are the passwords getting modified in this file? And that is because of this SUID. So what happens is, during the duration of the execution of this command passwd, as I said, 1 millisecond or 2 milliseconds, whatever it is, any user who executes that command becomes root. He is acting as if he is a root, and that is happening because of this SUID. The ownership is now switched to root for the duration of that execution, and because he becomes root for that duration, he is able to change anything in the file because he is the owner. So any other person can execute this command and will be allowed to change the password in the etc shadow file even if he does not have the permission to do so. So that is happening because of SUID, that is the chmod u plus s command and the name of the file. So this is what about special permissions is there. I would suggest that these two are probably very important, and this is not that important for the administrator because this is usually set for most of the C programs that usually are developed by the programmers. passwd is actually a C program, executable of C program. So memorize these two, and I think for any kind of collaboration, obviously you set the bit for SGID. So that is all about special permissions, and in the next section we will see the ACLs, the access control list.